In this example, we're going to solve this linear system using elimination. So the first thing to do is to make sure that the equations in the system are written in standard form. So that is x, y equals a number, and x, y equals a number. So it is important to have the equations in this form so that the like terms will be aligned vertically. So we have our x's stacked on top, our y's, and our constants. So we see that in this case both equations are already written in that form. So the process of elimination is going to combine the two equations in the system by addition, and in doing so we're going to create a single equation with only one variable, which then we can solve for. But in order for elimination to be effective, the coefficients of the variable we choose, they need to be equal in number but opposite in sign, so that when we add them, of course, they'll cancel out. So when I look at this first example is already set up in the form where we're going to cancel our y's out. So I'm going to go ahead and put a line underneath here because I'm going to add these two equations together. And if you'll notice the coefficients of my y's, they're both 5, but of course one is negative and one is positive. That means when I add them together, they will essentially cancel each other out. So let's go ahead and add these two equations together. 4x minus 2x will be 2x. My negative 5y and my positive 5y cancel each other out. And that will equal 6 plus 2, which is 8. So now it's just a matter of dividing both sides by 2, and x equals 4. So you'll notice what happened here. We had two equations with two unknown values, x and y. So when we added them together and we were able to eliminate the y's, we were left with a single equation with a single variable, which then we could find its value. So x equals 4. So now that we know the value of one of the variables, we need to go ahead and plug that back in to one of these original equations, and then we can finish by solving for y. So let's go ahead and do it in the second equation here. And the only reason why maybe is because the coefficient of my y variable is positive, so no reason other than that really. It won't matter what equation you plug it back into. So negative 2x, and my x is 4, plus 5y equals 2. So negative 8 plus 5y equals 2. So now it's just the process here. Add 8 to both sides. 5y equals 10. And y equals 2. So now I have effectively used elimination to solve this system. X is going to be 4. Y is going to be 2. And there's my ordered pair that is the solution to this system. 4, 2.